Hello, this is the video about the text classification, and I'm going to discuss how we can apply it with Python code. So you can see here, we need to import the libraries. Okay, you already know. Uh, we have the pandas, numpy, re. It is the regular expression, and we can use some built-in function from string. And we can use the model selection to train and test split. Some feature extraction, we can use the count factorizer. So we already know we can calculate the number of text, we can calculate the number of words. And yeah, we are going to use the naive Bayes library, which is the multinomial naive Bayes. And then we are using the logistic regression. And at the end, we are going to measure the accuracy score and yeah, the log loss. In this case, we are going to use the NLTK, and let's use the stopwatch. So it means that the important words only will be considered. Okay. So this is the library. Now let's look at this one. So we have a data. Let's say this is a corpus, okay, and there are 20 random complaints. So the complaints like this one: my street light is not working for a week, and there's water leak that needs fixing immediately. Crash pickup has been delayed by a day again, and so on. Okay. And we want to classify this whether it is 0, which is not urgent, or 1, it is normal, or 2, this is urgent. Okay. So if it is urgent, then it will be labeled by 2. If it is normal, this 1, also it means you can just fix it a little bit later. Okay. Or if it is not urgent, you can put it at level 0. Then we want to know, based on this word, how to make the model, and if we have a new complaint, what will be the best label, whether it is not urgent or normal or urgent. So the pre-processing, you may know already. Okay, we can convert to lowercase. We can remove the punctuation. Okay, so we can remove some extra white space. We can remove the stop words. So it means I am using the English words. Okay. And yeah, we can just join all the words that we already have into the text. Okay. So let me just create the corpus, and then let me do the pre-process. So you can take a look at the pre-process, the corpus clean. So this is the clean one. Okay. Street light working week. Okay, so the first sentence is my street light is not working for a week. Okay, so we just extract the important words. So this is the corpus after we clean it. Okay. And we can do the factorization. Okay, so you know already with the count factorizer, we can calculate the frequency of the words. In this case, we can create whether you want to create unigram or bigram or trigram. So I'm using the n-gram range. So it means we are going to make unigram, bigram, trigram at simultaneously. Okay. So we have the x. X means I want to use this factorizer in the corpus. Okay. Maybe let me just split this one. Maybe I can show you. So if we have the factorizer like this, then let's see, what is x? So it is not shown clearly because it is 220 multiplied 207 plus matrix. So let's keep it like this one. Okay, so this is the result from the n-gram, and then we can split it into x train and x test, y train and y test. In this case, we are using the 2080. Okay, and let's just make this random state like this one. Stratify label means we want to ensure that every label is in the what we call usually in the stratify label, every text will be of in the balance label. So we add the stratify parameters to indicate this label. And then, okay, this is the naive Bayes approach. The naive Bayes approach, we use the multinomial NB. This is the algorithm. And then we are going to fit the X train and Y train. I think you know, if we do with the machine learning, we will do the fitting. After we do the fitting, we can predict, okay? And then we can check the probability when we do the prediction. Okay? And then we use the logistic regression model. Okay. So here I put the maximum iteration as 1000. Actually, you can determine by yourself. When the number of iteration is high, of course, you can check the better weight. So you can find the optimum weight. Okay. And we use the model created by this parameter, and we put the X train and Y train, and we predict the X test, and we get the probability. Okay. I'm using the perplexity. I guess you already know the perplexity. So the perplexity is the we call it the exponent of the log loss. Okay. So if we have the perplexity is 2 exponent of the cross entropy, or usually we call it the log loss. Okay. And there is another metric, we call it accuracy. This is the common metric for the machine learning. So for the naive Bayes evaluation, we want to check the accuracy. So the accuracy means I want to check between the y test and the prediction. So the log loss means the y test and the the probability. And then the perplexity is the NB log loss. Okay. And this is the logistic regression evaluation, and we can see the result. Okay, using the naive Bayes, the accuracy is this one, and the cross entropy is 1.5, and the perplexity is 4.85. Using the logistic regression, the accuracy is 0.5, the cross entropy is this one, and the perplexity is 3.0 something. So this is the prediction on the naive Bayes, and this is the prediction on logistic regression. Okay, so it means there are 4 data that has been split as the test data, and the remaining will be for the training. And as you can see here, okay, 3 and 4.8, so it is almost 5. It means we have a better result for logistic regression, because smaller perplexity means a better one, and the accuracy is also lower. Okay. And also the log loss, or the cross entropy log, is lower. When it is low, of course, the perplexity is also low. Okay. So the naive Bayes shows not better than the logistic regression. In this case, we can use the logistic regression. There are many other variants. Of course, you can use SVM, you can use other things, and you can also deal with different parameters. For example, you can set the maximum iteration, and in the multinomial Bayes, there are some parameters like whether you want to use the alpha, okay, and for example, the logistic regression, you can also have different kind of parameter like C, and then what kind of solver that you want to use, and whether if it is multi-class or not, because if it is a multi-class, it will be different with the binary class. And yeah, you can make a better result with different parameters from this. In the next section, it is about the LDA. Actually, I'm going to mention about the LDA at the next class. Okay, but let me just explain a little bit about the LDA in this code. The idea of LDA, usually we use the LDA for the topic modeling, but we can also use for the text classification. In the text classification, if we use the LDA, yeah, you can download the library latent lyrics allocation. And again, we use the count factorizer and we use the label encoder. Okay. And we want to measure the accuracy. Okay. So in this case, yeah, again, I think it's the same with the previous one. We can do the pre-processing and then we will make the representation. Yeah. So the representation, it is good if you use the unigram. Of course, if you want to do with the bigram and trigram, there will be some more advanced ways to deal with that one. But let's say the example with the unigram, and then we want to factorize it into x. And once we use this factorizer, we want to encode the labels. Okay, so the label encoder means we want to encode it for the LDA. And yeah, we can use the LDA with how many components that we want to use, because there are 3 topics or 3 categories. So let's make with 3 number of component is 3. So this good for the topic modeling, because if we want to say that how many topics that we want to generate, let's say we want to generate 5 topics, so we can just make the number of components equals to 5. So we can do the splitting, training and the testing, and then we can do the prediction. Okay, so the prediction means we want to know what is the maximum. Okay, so the maximum from the value from the LDA. If it is the maximum, then yeah, we can say this is the predicted trend, and if it is the maximum from the test, then it is the predicted test. So we can calculate the prediction, and let's run. Pre-process text. Oh, I think I missed this. See. Okay, I need to do with the corpus clean maybe for better. So we are going to use the fit transform. Yeah, we use the corpus clean. Yeah, actually, if you want to use the preprocessed text, in this case, I use the corpus clean. Where is the corpus clean? Okay, so I can apply this one. Okay, oh, there are still some errors. Maybe I need to fix it again. Yeah, anyway, I'm not discussing the LDA at this moment. Okay, so I just want to show that, okay, there are some errors. I need to check again what is the error. Anyway, we will discuss more about the LDA in the topic modeling or the week 6. Okay, and let's keep this one for a later part on the week 6. Okay. So I will finish this video, and yeah, I'm sorry for this error. I will check again and I will try to update this before the next class. Okay, thank you very much for listening to this class and have a good day.